So please make note of it. So ma'am is posting the roll number who are not submitted the paper. So if your some paper is not visible, so if you are submitted today means you will get a mark, or else you are going to award a 0 mark for your paper. Clear? Yes, ma'am.
10 minutesல போட்டா மட்டும் தான் சார் எடுத்துக்குவோம். நான் நேத்து கால் பண்ண சொன்னா காலே பண்ணல. குரூப்ல போட்டா மதிக்கிறதே இல்ல.
அவங்க எதுவும் பேசுறதே இல்லையே. Okay, the solid state speed control of DC motor. So in this, while talking about the solid state drives, we are going to control the speed of, as like I told you before, we are going to control with the turn on or turn off the motor with the help of a power electronic semiconductor devices. So what are all the power electronic semiconductor devices? Maybe is a thyristor. With the help of thyristor, we can control the speed of the motor, and then IGBT, and then MOSFET. So it may be either a fully controlled or off control or a semi control method. So there are some methods which we have used for the speed control of DC motor by properly turning on and turning off the switches. It may be a thyristor switch, SCR switches, or it may be IGBT, or it may be a MOSFET switch. With the help of the circuit diagram, you are going to control the speed of the DC motor. Okay, that is nothing but we are going to turn on and turn off the switches, or else we are going to change the firing angle of the thyristor which are connecting to a circuit. It may be a self-excited DC motor, or it may be a separately excited DC motor. So these are the so it is called as a solid state speed control method. So there are two types over there. One is phase controlled rectifier fed DC drives, and another one is the chopper fed DC drives. Yes, what is that? Phase controlled rectifier fed DC drive, and then another one is the chopper fed DC drive. So these are classified further classified into many types. So we don't want to go to the types. We want to know, simply want to know about what are the blocks over the rectifier fed DC drive, and what are the blocks that you are having in the chopper fed DC drive, and what is the advantages and disadvantages of the rectifier fed DC drive and chopper fed DC drive. Okay, we will see these things by one. Okay, first of all, we want to know what is the purpose of the phase control rectifier. What is the purpose of the rectifier? The rectifier is the circuit. It is used to convert the AC supply into a DC supply. Okay, that is AC supply is converted into a DC supply with the help of a rectifier circuit, and then it is given to the DC motor, and then it is coupled with the load. So please recall the diagram which we have drawn for the that is DC motor, block diagram of a DC motor drive. So DC drive, AC drive, we have drawn the diagram now. So please recall over that. that what is that phase controlled rectifier, it replaced by the power electronic devices. Okay, so we are using here we are using the rectifier circuit. Clear? And then as like the chopper circuit, we'll see the rectifier and chopper by one. Okay, clear? So first we are moving on to the phase control rectifier FET DC drive. So please draw the block diagram over there. It is phase control rectifier FET DC drive block diagram. So please draw the block diagram. Block diagram. So this is important. So now finish. So it resembles the block diagram which we have already seen during the module 1. So this is the block, that is first is the AC source. We are giving a AC source. So it may be it is a single phase supply or three phase supply. So depending upon the supply which we have given to the phase control rectifier, so it can be there are many types over there. So I will discuss in the type section. So if it is a three phase or a single phase supply, it is given to the AC source. So it is directly given to the output of the AC source is given to the phase control rectifier. So what is the purpose of the rectifier? Rectifier can convert the AC voltage into a DC voltage. So here the rectifier is converted into a AC voltage into a DC voltage. That we are using, as I told you before, that we are using the power electronic semiconductor devices. That is, it may be a there we can employ the rectifier. That is, we can employ the SCR and diode combination, or else we can. It is if it is off controlled means we can use as the rectifier and diode circuit. If it is fully controlled means we are using the thyristor for the control. So what is the purpose that is the switches which we are using for the speed control of the DC motor. So that here it came into the part that is phase control rectifier. Phase control rectifier, we are using the power electronic devices. So in this portion, what will be happen? The AC voltage which we are given as the input to the phase control rectifier. This rectifier will converts this AC voltage into a DC voltage. Okay, that is nothing but by the suitably by changing the firing angle of the SCR or thyristor or IGBTs that we have used in the rectifier circuit. This AC voltage is directly converted into a DC voltage. So after converted into a DC voltage, it is the output it is given to the DC motor. Okay, so depending upon the output which we have getted in the phase control rectifier, that is due to the turning on and turning off of the thyristor, the speed of the DC motor can be varied. The speed of the DC motor can be controlled with the help of the switches that we have used in the rectifier circuit. Okay, and then it is directly coupled with the load. The load may be the application which we have used over there. Clear? So it may be it is used for as like we told you before, it is used in the many industrial purpose, paper mills, different types of mills, steel mills, textile mills, or else it is can be used for the traction purpose, elevator, etc. So these are all some example where we have used the phase control rectifier FET DC drives. Clear? So there are certain advantages over the phase control rectifier FET DC drives. So what are the advantages? Means it is simple, unreliable. It is nothing but it is construction is simple as like it is compared to other drives, and then the time response is faster. Efficiency is also very high, and then size smaller in size and less weight. So and then cost is also so these are some advantages which we are going for the rectifier FET DC drives. Okay, clear? Okay, it's nothing but we are using this is the block diagram. We are having only block diagram representation for both the rectifier and chopper. So it is phase control rectifier FET DC drive. That is this is the block diagram over there. So first block it has AC source. Second block it is phase control rectifier. Third is the DC motor, and the fourth is the load. So you can explain. If you are writing in the exam, you want to explain each and everything by one, step by step. I will give you the notes. We will give you the notes. The notes we are having, what we are talking is over there. Clear? So this AC supply. So depending upon the input supply you are giving to the chopper, rectifier FET DC drive. So it may be single phase supply or three phase supply. So that is given as the input, and it is given to the phase control rectifier. So this phase control rectifier, we are giving AC supply. AC supply is directly converted into a DC supply. So here we can employ the rectifier circuits. So the power electronic devices is came into an account. That is switches is takes place. It's connected to directly coupled with the motor, and then by changing the firing angle of the SCR, the on and off of the motor can be takes place. So with the appropriate techniques we can follow, the speed control of the DC motor can be controlled. So it is directly coupled to the application which we have seen before. So this is called as the phase control rectifier FET DC drive. So please note the advantages also. So because it may be asked in the 2 marks. So this is the important question in the module 3.
சார் லெட்டர் கொஞ்சம் பெருசா எழுதுங்களா சார்?
எதுமா? எல்லாமே வா?
எஸ் சார்.
ஓகே ஓகே. Is okay now?
Yes, sir.
So these are all the advantages for the phase control rectification. We completed the. We completed this.
No, sir.
Okay. So depending upon the types over the, so it is not having in syllabus. Just you want to know what is the types. That is the single phase half wave converter and single phase semi converter rectifier drive and single phase fully controlled rectifier drive. These are all the categories that we are having in the single phase supply. If we are using the single phase supply means we want to use any one type of converter over here. Okay, clear? And then the if it is a three phase means again in three phase it has separately excited motor or self excited DC motor over there. So depending upon this, it is also converted into the that is fully controlled self excited, fully controlled separately excited converter. So these are all the converter circuit that we have used over here. Okay, so any one type of converter circuit that we are using over here, that is used to drive on the DC motor. That is, we are going to control the speed control of the DC motor over there. Okay, so for example, you are having a circuit diagram. I will just draw you one circuit diagram over there. So that is, can I rub this? Can I rub this block
sir.
diagram?
Yes, sir. Yes, sir.
So for example, I have drawn the circuit diagram of the single phase half wave converter. So for example, you are using the AC supply over there. So this is the circuit diagram. This is thyristor one. We are using only one. It is diode one. Here we get so for example, I have gotten there what is the single phase half wave controller, half wave converter. So we are using only one diode and then one thyristor over there. Here we are giving AC supply. So after this conversion takes place by changing the firing angle of the thyristor. So it is a half controlled rectifier. We are using only one thyristor and the diode. So after that, the supply is converted into a DC supply and it is given to the motor. So this is one example, that is why we are using a half wave converter over there. If we are using the second type, that is single phase semi converter drive. So if it is a semi converter drive means in spite of this one thyristor and one diode. We are using two thyristor and two diode for the operation. And then if you are using that is the semi converter drive. If you want fully converter drive means we want to use whole thing, that is 4 thyristor we are using. So depending upon the application, this circuit alone changes. Okay, nothing but here if it is one thyristor and one diode, so same is replaced by the thyristor and then diode, and another one thyristor and then diode. So if you're using this circuit which is over there, so it is called as the single phase semi converter drive. Okay, while we are using it is a fully converted drive, we are using these 4 switches as a thyristors. So this is called as single phase half wave converter, semi converter, and fully converted. So this is not having in syllabus, just for you, for the understanding purpose, I will show you this. So this, okay, you want to write only the block, want to write only the block diagram which I have discussed in the previous session. That is nothing but we are having only block diagram representation only. For your understanding purpose, I have explained you the things over here. Clear? Clear? If you are having any doubt, please ask me, or else I can move on to the next is chopper fed DC drive. Okay, while we are finishing this chopper fed DC drive, then we will move on to the wall near system and then lab system. If you are having any doubt over here, can you able to follow me?
Yes, sir.
Okay, and move on to the next topic, that is chopper fed DC drive. Okay, clear? please make note of this block diagram. So please make note of this block diagram. Clear? Finish? Did you copy the block diagram? Yeah? Yes or no?
No, sir.
Okay. Finished? Finished? முடிச்சிட்டீங்களா? So as we saw in the last circuit, that is in the rectifier circuit, there we are using the AC voltage is given as the input, that is in the source. So here in the source it is given as the AC source. So we are going to control the speed control of the DC motor. So only we want to control that AC into a DC. Okay. So with the help of the rectifier circuit, and then it is connected to a DC motor. That is the DC in DC it is nothing but a variable DC supply. By the turning on and turning off the power electronic switches, you are going to control the speed control of motor. That is the rectifier circuit. As as we is shown in the last circuit, here it is a DC chopper circuit. Here you are using the input supply as a DC supply. So DC supply, it is nothing but the DC supply is a constant supply. It is a fixed supply. So we want to convert that fixed supply into a variable DC. For fixed DC into variable DC, we are using this chopper circuit. So chopper is the device that is used to convert a fixed DC voltage into a variable DC voltage.
Sir.
Yeah, சொல்லுங்க.
So mic off ல இருக்கு sir.
என்னோடதா?
இல்ல சார் நல்லா தான் சார் கேக்குது.
ஆடியபிள் சார்.
கேக்குது. ஆடியபிளா?
எஸ் சார் எஸ் சார்.
எஸ் சார்.
ஓகே.
எஸ் சார் ஆடியபிள் சார்.
Okay, okay. Clear? So, where I stop, that is the fixed DC into a variable DC. So there we are using only the AC supply as the input. Here we are using the DC supply, that is fixed DC. We want to convert into a variable DC. So with the help of the DC chopper, as like we shown before, here also we are using only the power electronic semiconductor devices, that is SCR, IGBT, and then MOSFET for the controlling purpose. That is, we are going to turn on and turn off the switches. We can get the speed control of the DC motor. Clear? So here the chopper circuit, DC chopper circuit, chopper is nothing but it is convert DC into DC. Chopper circuit, it fixed DC into a variable DC supply. Convert the fixed DC into a variable DC supply. After, from over there, here we are getting a variable DC supply with the help of the power electronic semiconductor switches over there. It may be a SCR or thyristor, IGBT, MOSFET that can be employed as we shown in the before diagram. Like that, we are also here also having chopper circuit. The rectifier circuit, here it is a chopper circuit. So with the help of the arrangement over there, we get the voltage as the output, that is the variable DC as the output. So by changing the voltage which is getting over here, we can control the speed of the DC motor. Clear? Okay? Clear? By varying the DC variable DC voltage with the help of the chopper circuit, which is employed over here, with the help of the power electronic semiconductor switches, we can get the variable DC voltage over there. By controlling the variable DC voltage over there, we can control the speed of the DC motor. Voltage changes means speed also automatically changes. Okay, clear? So we can get the speed of the motor, and then it's coupled with the load, that is nothing but the application of the chopper fed DC drive. So here it can be used in the battery operated vehicles, where we are using only a DC battery as a source, or else it is in the DC traction purpose, that is in the railway purpose, train motors for controlling the speed of the train. In traction purpose, this chopper fed drives are used, or else in the trolley, cars, cranes, and lifts, where else we are using the DC and battery source as a input supply. There we are using only the chopper fed DC drive. Okay, so these are all the application over there, and the advantages as like it has a higher efficiency, and also it is very flexible. It has flexibility control, and it is lightweight. Due to the power electronic semiconductor devices, it has only lightweight, and also size is also very less, and response is also greater due to the usage of the power electronic semiconductor devices. Clear? So these are all the advantages, applications of the DC chopper FET drives. Okay, so up to this we can write it for the syllabus. So beyond the syllabus, we want to know what are the uh, types of the chopper FET DC drives over there. So as like there we are controlling the single phase fully controlled, semi controlled, and half-wave controlled rectifier. Here also we are having the types of chopper circuit. So there are nearly we are having 5 types of chopper circuit over there. So we all know the multi-current operation. Depending upon the current operation, this chopper FET DC drive, that is one is motoring mode, braking mode, forward motoring mode, reverse motoring mode, forward braking mode, reverse motoring. Like that, we are having 4 current operation, which we have already discussed in the previous classes. So during that first quadrant, second quadrant, third quadrant, and fourth quadrant, the chopper FET drives are categorized. So the that is the first quadrant drive or chopper type A chopper, and second quadrant type G is chopper, and the 2 quadrant type A or type C chopper, type C, type D, and then type E chopper. Up to 5 operation are there, 5 types are there in the chopper FET DC drive. So for each set of choppers, we are having, as like we seen before in the circuit operation for the fully controller drive and off control drive. Here also the this chopper circuit diagram remains changes for type A, type B, type C, type D, and type E choppers. Okay, so that is not having in your syllabus. Just know what are the things happening over there. That is the main purpose of the chopper. It is going to convert the fixed DC voltage into a variable DC voltage. Clear? Having any doubt over there? And also there are different types of control strategies that have been used in the chopper. That is the time ratio control and the current limit control. It is nothing but we are changing the fire angle that is given to the SCR. So SCR fire angle can be changed with the help of the time limit and current limit control. So that is and all not having in your syllabus. You just know about the block diagram and what are the blocks over here, what is the purpose of this block, and what is the application over there, and what is the advantages of the Madam. Ma'am, Vidya ma'am. Yes, is audible.
Yes, sir.
Okay, we will move on to the next is that is the wall linear system. Okay. Still doubt you are having any doubt in this the rectifier and chopper FET DC drive? Vidya ma'am.
சுரேஷ் சார்.
No, okay ma'am, okay ma'am. So move on to the wall linear control system. Am I audible? Am I audible?
Yes, sir.
So this is one important question over there. They may be asking both the CAA and also in the in some examination. So diagram is very important. Circuit diagram or sorry, block diagram. So please draw this diagram. Please draw this diagram. So you draw the diagram. Did you finish the diagram?
No, sir.
Okay, first. Finish, guys. You finish the diagram.
Yes, sir.
Okay. So what we have seen in this diagram, the diagram in என்ன தெரியுது? So here we are using two motor and one generator. Okay. So we are going to control three things, that is motor 1, motor 2 and the generator. Okay. So what are the things? First, just analyze what are the things over there in the diagram, that is ball linear control system. What are the things we are having there? So the system was introduced during the 1890s. So after this system only, we can evolve. There is evolution of a DC drive. There is significant evolution of the DC drive, and improvement of DC drives are taken into account after the invention of this ball linear control system only. So just see the diagram. There are two motors, that is motor 1 and motor 2. Motor 1 is directly coupled with the generator. Okay, that is the shaft of the DC motor is coupled with the generator, and then again this generator is coupled with another motor, that is motor 2. So this is called as main motor, and this is called as a control motor. That is given supply is given to the shunt field, shunt field winding. There are two shunt field winding over there, and here it is a regulator, that is field regulator, and then rheostatic control. With the help of, there are two switches that is connected over there, that is called as reverse switch. So that is particularly this arrangement is used to control the speed of the motor 2, that is M2. So we can, what is the purpose of that reverse switch is to change the direction of the motor 2. So this is the main purpose over there. So by controlling the field regulator, that is the rheostatic control over there, we can control the speed of the motor. So we can control in this type, we can control both the methods which we have discussed already, that is field control method and armature control method. Both the control are possible in this arrangement. In this single arrangement, we can control both the field control method and also the armature control method are all possible in this type of Wall-Niander control system, because we are giving directly armature is motor armature is given supply, and then is control with the help of the field regulator. So we see what are the things happening in the Wall-Niander control system one by one. So what is the first step over there? This motor 1 and generator is directly coupled. The motor 1 is power the generator. So first it is set with a constant speed. So both the generator and the motor 1 is set at a constant speed. So if it is run at one speed, means if, for example, its RPM is 1400 RPM, we are taken into account of 1400 RPM. This generator is also made to run or couple with each other to run at same RPM speed. Okay, so generally there are two motors, that is the motor 1 and motor 2. So motor 2 is control motor, motor 1 is main motor, that is coupled with the generator. Clear? Okay, so what is the uses? So generator, that motor 1, this M1 and G, that is motor 1 and generator to set the power of the DC motor drive, that is the each motor and generator is run at the constant speed over there. So here M1 is the main motor, it is directly coupled to the DC generator. So DC supply, here the DC supply is given, here it is the armature, so armature of the motor 1. So armature control is also possible over here. So armature is given supply with the help of the motor 1. In motor 1, armature terminal is given supply, and also the as well as shunt field is also giving supply with the help of the DC bus which is going over there. So the DC bus is the bus which is given supply to both the shunt field and also the DC motor. So from the generator, the power driver, it can be fed to the motor 2. So these two are coupled each other. So only it is called as a controlled motor. So during this operation, first one, what will be happen? So motor 1 and generator is run at a constant speed. So if it is run at a constant speed means, so speed matches such a it will be run at a constant speed means both are running in a simultaneous condition. That is, it can be run at a constant speed. So Now, what the step we want to take over there means the voltage of the generator. So, the voltage of the generator, this can be varied. So, this can be varied from 0 to maximum percent. So, with the help of the field regulator that is in the circuit, with the help of the rheostatic control method, from the minimum percent to the maximum percent, we can control the speed of the DC generator, okay, with the help of the field regulator over there. Okay, so the generator DC voltage is fed to the motor 2, that is the controlled motor. So this controlled motor rotation can be changed with the help of the reverse switch. So if it is run at one particular direction, if you want to change this to another direction, means this can be changed with the help of the reverse switch. Here we are having two switches. So normally it operated in this direction. If you want to reverse, change the polarity, we can activate this switch, that is RS switch, reverse switch. With the help of the reverse switch, what will be happen? The direction of the field current of the generator can be run the generator on the motor 2 in the reverse direction. The motor can be run at the reverse direction. Okay, clear? So the speed of the motor is controlled by the number of field turns that can be in the field regulator system. Okay, clear? So this method is applicable for both the what is that? There are two control method. No, ரெண்டு control இருக்குல்ல. So என்னென்ன control இருக்கு? That is base speed and then high speed. ரெண்டு speed இருக்குல்ல, base speed method. That is both the armature control and then that is field control method. Both the method controlling strategies is possible due to the this wall linear control system. Clear? So by combining both the armature and field flux control method, these two are possible in this wall linear control system. Okay, so here the armature voltage, how we change the armature voltage? The armature voltage can be changing by changing the field. By changing the field, we can control the armature voltage, that is the motor 1. Clear? And the flux control can be achieved by varying the field of the DC motor. Okay, clear? The armature voltage can be achieved by varying the field of the DC motor. The flux method also achieved by varying the field of the DC motor over here. So both the method, that is armature method and then the field control method, both the method are possible in this wall linear control system. Clear? We can combine the armature control method and field flux control method with the help of this system. Okay, clear? Clear? So we are move on to the lab session, that is same wall linear control system. With the help of the diagram, we can change, given the supply to the motor, with the help of the armature and field control method, we will get a clear idea about it. Okay, so just we are move on to the lab session, that is week labs. As we do it before, we can move on to the session. Okay, so with the help of that, we came to know the both the armature control method and field control method are possible in the single wall linear control system. Clear? Okay, Vidya ma'am. Vidya ma'am? So all நம்ம இதுக்கு முன்னாடி பண்ணதே தான் சேம் V labs. So இந்த எக்ஸ்பெரிமெண்ட் வந்துட்டு it is wall linear control system method. My screen is visible. So move on to the VLAB. VLAB co.in. In that, select electrical engineering as we do it before classes. Go on to the electrical machines lab new. So in the electrical machines lab new, we are having this. So in this, click the list of experiments. There, fifth experiment to perform a speed control of DC motor by using wall linear method of speed control. Just click over there. Just simulation. Guys, you are following me? As I told before, the motor, generator, and another motor. Just follow the collection over there. So first one, connect a point A1, B1, C1 of the MCB to the input of auto transformer A2, B2, and C2. Connect output points E1, F1, G1 of the auto transformer to E2, F2, G2. And third is connect point D1 to the DC supply to the point of D2 of starter. You're following me? The screen is visible? Vidya ma'am?
Yes, sir.
Okay. And then the connect point H1 to H2 of the rheostat and connect point J1 of the starter with J2 of the voltmeter with point I2 of the DC generator. So connect I2 of DC generator with point M2 of the DC motor. So just we want to step what is giving on here. So first connection A1, B1, C1 to A2, B2, C2. A1, B1, C1 to A2, A1 to A2, B1 to B2, C1 to C2. So the first is over. Next point, connect output point of E1, F1, G1 to E2, F2, G2. Clear? Third point, D1 of the DC supply with D2 of the starter. K1 of the DC supply with point M1. K1 to M1. K1 to M1. K2 to L1. H1 of the starter to H2 of the rheostat of I1 of DC motor. H1 of the starter to H2. Connect J1 of the starter, J2 of the voltmeter. Starter to J2 of the voltmeter. I IP of the DC generator with point M2 of the DC motor. I2 to M2. M1 of the DC generator with N1 of the DC motor. M1 to N1. N2 with O1 of rheostat. L1 of the DC motor with L2 of the voltmeter. L2 of the voltmeter with point M1. L2 to M1. So please see the instruction. Some wrong connection. A1 to correct. Vidya ma'am. Vidya ma'am. Anyone getting answer? Correct connection?
Yes, sir. I am getting, sir.
You're getting.
Yes, sir.
What is the
Yes, sir. Getting, sir.
okay? What is the என்ன தப்பு இருக்குன்னு பாத்தீங்களா? ஏதாவது தப்பு இருக்கா? The circuit diagram. First step is correct. I think so. A1, A2, A1, A2, B2, correct. And then E1, F1, G1, E2, F2, G2, correct. Second point is also correct. Third point, E1 and D2, E1, D2, is correct.
சார் K1ல இருந்து K2க்கு ஒரு கனெக்ஷன் போகுது சார்.
K1 to K2,
எஸ் சார்.
K1 to K2. Okay.
அதே மாதிரி K1ல இருந்து L1க்கு ஒரு கனெக்ஷன் போகுது சார்.
Okay. So step by step போயிடலாம். உங்களுக்கு கிடைக்குதா?
எஸ் சார், எங்களுக்கு கிடைக்குது சார்.
Yes, sir.
ஜஸ்ட் அதை ப்ரெசென்ட் பண்ணுங்க.
Okay, sir.
அதுக்குள்ள நான் பார்க்குறேன், செக் பண்றேன் நான். So A1, A2, E2, E1, Okay. Okay, Balaji.
Okay, sir.
So press something. This is getting this. Okay. I can. So this is the circuit diagram as Balaji myself. So please follow this. Take a screenshot over there. Please post in the group also, Pa.
Okay, sir.
Okay. This is the thing. The connection is correct. So what we want to do? So just first we want to turn on the MCB. So MCB, and then as the previous experiment, double tap the auto transformer, we will get the voltmeter reading. And we want to restart. Doing knob of the restart, we will get the voltmeter and the speed of the reading.
ஏன்பா சரிப்பா
Just we get the value like that. With the help of by varying the DC generator, we can get another. We can get the same reading. Reading. So here. We can get the graph over there. In this graph, we can conclude that both the armature, by comparing both the armature control method and gateless control method, both the graph can be achieved with the help of this ball linear system. Okay. So this is the graph over there. So please make note of it. I have posted in your group. This is the correct diagram. We can get the value and graph over there for speed and voltage. So this is the motor number 1. This is generator, and this is controlled motor. We can control both by the armature control method and field control method. So two things are possible with the help of this ball linear control system. All are getting this value? Guys, you are getting this value? So that 3 பேர் சப்மிட் பண்ணிட்டீங்களா பேப்பரு? மேம் போஸ்ட் பண்ண நம்பர் சப்மிட் பண்ணிட்டீங்களா?
சார் ஒருத்த மட்டும் தான் சப்மிட் பண்ணிருக்கேன் ப்ளீஸ்.
ரிமைனிங் 0 தான். வித்யா மேம்.
சார் சொல்லுங்க சார்.
மேம் இதுக்கு அந்த இது சப்மிட் பண்றதுக்கு கிரியேட் பண்ணிடுங்க மேம்.
சரிங்க சார். சார் அப்புறம் இந்த யூனிட் டெஸ்ட்
அதான் மேடம் எல்லாமே கேட்டுட்டே தான் இருக்கும்.
சார் 0 போட்டு க்ளோஸ் பண்ணிடலாமா சார் யூனிட் டெஸ்ட்?
அப்படிதான் பண்ணணும், வேற வழி இல்லை மேம். நீங்க பாருங்க இப்பவே 60 பேர் தான் இருக்கீங்க. 60 பேர்ல என்னோட லாகின் 3 லாகின் இருக்கு. 54 பேர் 55 பேர் தான் இருக்கு.
எஸ் சார்.
எப்பவுமே இதே தான் நடக்குது. the time of starting 78 மேம் இந்த 62 மட்டும் அட்டெண்டன்ஸ் பண்ணுங்க மேம். வித்யா மேம்.
சார் சொல்லுங்க சார். இருக்கேன் சார்.
இப்போ இருக்கு அந்த 62 மட்டும் அட்டெண்டன்ஸ் பண்ணுங்க மேம்.
சரிங்க சார். 62 மட்டும் இப்போ பிரசன்ட் கொடுத்துறேன்.
பொறுத்துக்கு டியூட்டோட சொல்லுங்க.
சரிங்க சார்.
வேற யாருக்கும் கொடுக்காதீங்க, இன்னைக்கு வந்துட்டு போனவங்களுக்கு எல்லாம் கொடுக்கலாம். இல்ல இந்த செஷன் எப்பவுமே இப்படிதான் இருக்கு. லேப் எதுக்கு நடத்துறதுன்னு தெரியல.
சரிங்க சார். இதுக்கு அட்டெண்டன்ஸ் போடணும் போட்டுடலாம் சார்.
அட்டெண்டன்ஸ் நீங்க ஆப்சன்ட் போட்டுருங்க மேடம். இதே நாம தான் யூனிட் டெஸ்ட் வச்சு யூனிட் டெஸ்ட் வைக்கிறப்ப 40 பேர்த்த காணும். என்னதான் பண்றது? பட் ஆனா எல்லாரும் 25 மார்க் மேல. என்ன மேடம் கரெக்ட் தானே? ஹலோ வித்யா மேம்.
சார் சொல்லுங்க சார். இருக்கேன்.
எல்லாருமே குட் மார்க்ஸ், அதுதான் எப்படின்னு தெரியல கிளாஸ் அட்டெண்ட் பண்ணாமே. பாத்துக்கோங்கம்மா, இதை சப்மிட் பண்ணிருங்க. ஓகேவா மேம்? இது 5வது எக்ஸ்பெரிமெண்ட் தானே மேடம்?
4ங்க சார்.
அது ஆர்மேச்சர் ஃபீல்ட் ஃப்ளக்ஸ் கண்ட்ரோல் 2
ஆமா
எடுத்துக்கலாம்.
சார்.
ஓகே மேம், 4 எக்ஸ்பெரிமெண்ட் முடிச்சிருக்கோம். எத்தனை பேருக்கு 0 வாங்க போறீங்கன்னு தெரியல. ஆல்ரெடி 2 எக்ஸ்பெரிமெண்ட் நாங்க ஆல்ரெடி மார்க் கொடுத்துட்டோம். எல்லாரும் மேக்ஸிமம் சப்மிட் பண்ணிருப்பீங்க. அதுலயுமே 70 பேர் சப்மிட் பண்ண அப்படிதான் பண்ணிருக்கீங்க. எல்லாம் பாத்துக்குங்க. அப்புறம் ஃபைனலா இதை வச்சுதான் இன்டர்னல் மார்க் வரும். அப்போ அதுல ஏதாவது டிவியேஷன் தெரியாதுங்க. So by this we can conclude the speed control of DC motor. The speed control of DC motor, shunt motor, series motor, ball line control system முடிஞ்சிச்சு. So from next class we are going to take the speed control of AC motor. அந்த AC motor முடிச்சு slip power recovery scheme ஒரு டாபிக் இருக்கு. முடிஞ்சிச்சுன்னா we are going to complete our module 3. இன்னும் ஒரு 2 இல்லைன்னா 3 கிளாஸ் தான் முடிச்சிருவோம். ஓகேவா? பாத்துக்குங்க. சிலபஸே முடிஞ்சிருச்சு. நாம எந்த லெவலில் இருக்கிறோங்கிறத நீங்க இன்னும் பாத்து மைண்ட் பண்ணிக்கலாமா மேம்?
ஓகே சார்.
ஓகே, தேங்க்யூ மேம்.
தேங்க்யூ சார்.
சார் இது எதுல
இந்த மேம் போடுவாங்க. மேம் வித்யா மேம்.
தேங்க்யூ சார்.
வித்யா மேம். மேம் ஒரு லிங்க் போடுவாங்கடா யாஷ் சொல்லுவாரா?
ஓகே
அதுல போஸ்ட்.
ஓகே சார்.
சரியா?
ஓகே சார்.
சரிம்மா.